Okay. Happy Monday, everyone. This morning, unfortunately, Joe Reese couldn't join us, but I have our guest, Alex Gallego, who is the CEO of Redpanda. So it's a real privilege to have you here. Do you want to introduce yourself briefly and maybe talk about your background and how you decided to kick off the company and the kind of those basics?
Sure. Thanks, Matt. Thanks for having me. Yeah, Alex, original dev for Redpanda, and so I guess by means of introduction, grew up as an engineer, ended up building the first version of Redpanda, which is, if for those in the audience that know what Kafka is, it would be a Kafka replacement for mission critical systems. The whole thesis and idea behind it is I wanted something that was super easy to use, and so I started hacking in the code base in 2019 as a single binary. And it was really trying to solve a personal need of trying to build something that was super easy to use, really fast, and didn't lose data. Those were the three core pillars of the product. And it, honestly, naturally took off. Developers really jive with those ideas. They love using the product. And then I ended up building a company around it. I think middle of 2019, I hired my first friends, to be honest. And here we are 5 years later. So just thriving and with a bunch of, I think, Fortune 2000 logos in the company. So excited to be here. Thanks for having me.
Yeah, it's fantastic to have you here this morning. I mean, what was the key thing that pushed you to go from having this be a hobby project where this is technology you're interested in to making it into a company and raising money and doing all the insane stuff that you have to do as a CEO of a startup to get things off the ground?
Yeah, exactly. Prior to this, I had found and started another company. It was a stream processor. So think of it like an Apache Flink, also written in C++, that I sold to Akamai in 2016. And so it definitely took a few years for me to recharge and be in the sane mental space. But to be honest, when I was at Akamai, I think in 2017, I did a test of super fast RPC mechanisms. And so the idea is like, hey, how fast can communication between two computers get with open source technology? So I took DPDK, this Intel kernel bypass technology to effectively, when you get a write on the NIC, it onboards into the application memory space. And then you build a log around it just for fun. And then I wanted to compare it with, at the time, state-of-the-art Kafka. This was 2017, so a few years even before I started the company. I gave a talk about it, and I just kind of became fascinated about the capabilities of hardware. I was like, wow, hardware is so fast, but a lot of the things that we had built were built for a decade-old bottleneck in computing, which was the clock tick of the spinning disk. And so if you were to reimagine these things, what would you do differently? And a friend of mine, Kelsey, likes to say, sometimes you get to reinvent the wheel when the road changes. And so anyways, that kind of that was the technical impetus. I was just trying to, figure out from a blank slate, how would the world look different? And then I started writing about this, as in, I gave a talk in 2017 about RPC latency stuff. And then I think some friends from Snapchat, they're like, hey, if you built this, let us know. And then a couple of friends from the largest electric car company in the world, they're like, hey, if you build this, let us know. And then a friend from Europe from a large telco. And so when I built this, I wrote a couple of posts. I was like, hey, this is the gap, just objectively, between what hardware could do and what software could do. And then I built a private version of this, honestly, quite different from what the product looks today. It was using flood buffers for basically trying to prevent CPU serialization using little India encoding between two computers. And so the idea was like as fast as possible, as low latency as possible. It turns out most people didn't know what to do with the additional microseconds of latency, as in the application space, the vast majority of people, and obviously exclude the HFT folks that have been trained to game the microseconds, but for most people, most applications just aren't computing in the microsecond space. And so then I added a Kafka protocol on top, or we started with a couple of friends, we added the Kafka protocol on top, and now all of a sudden, this Docker image that we had posted with the code every release, basically every code check-in we pushed, started getting used hundreds of times. And I was like, wow, this is a real company. And then I moved to San Francisco, and story for another time, because from Miami to San Francisco just to try and see what it was like. I had lived in New York for a decade. I had lived in Miami for a couple of years. I was like, oh, I'll just move to San Francisco and see how it goes. And then I moved here, and everything just sort of took off. And it's not too dissimilar from what some of the audience members would think San Francisco is. It is very much like it's very easy to sort of network with people that are looking to fund young companies. And so we sort of had the right cocktail. We had a bunch of like large companies willing to put hundreds of thousands of dollars worth towards like new software. It worked, right? Like it was tested in one of the largest clusters for a bunch of large social media companies. It was tested for large electric car companies. And so they're like, hey, this sounds like the right thing. And I said, why not? And it's just been this organic explosion. Then at the end of that year, we released it as source available, and we went from hundreds. I think I was trying to measure the downloads to thousands to hundreds of thousands, and now we're in the millions of downloads a month. And so it's very much, I think that there was basically this need of people feeling frustrated with the distributed system whack-a-mole that it was to run, systems like Apache Kafka. It's just like, there's like 5 or 6 systems that you have to tune and tweak and knob and be an expert on to get something to run at a scale. But that was the journey. It was, we had, I guess, the right technical thing with the right orders of magnitude sort of difference in the product. We had a great group of friends that were distributed system experts, storage nerds, and then we had the right market timing. At least people convinced me that it was the right market timing. So here we are 5 years later.
Yeah, it seems like when you look at startups that are successful in retrospect, you kind of see two things. So there are startups where it's like they're pushing a big boulder up the hill, up the hill, up the hill, and then eventually they get to the top and the boulder starts rolling downhill. And then there are these others where they start off and the boulder immediately starts rolling downhill because it just happens to meet. It's like there's no need to tune product market fit because the need is already there and it's just completely aligned, and it kind of blows up. So I feel like I've talked a lot about streaming over the last year, certainly in various talks. And I mean, I think it's a concept that's not only here to stay, but like really poised for growth. Like we really are just at the beginning of this journey to see streaming grow a lot outside of your core tech companies. And so technology like this arrives at just the right time. Let me ask you one technical question. So you talked about like data processing in the NIC, in the network interface card, so getting really low into the hardware level. Were you getting like right into the kernel? Were you writing code that like accessed the Linux kernel to do that, so that you were bypassing some of the abstractions that you typically pass through?
Yeah, so great question. So the Linux TCP stack is super mature, sophisticated, and in part it has a bunch of code for legacy hardware, but also a bunch of like legacy bugs that throughout time, Akamai is like notorious for finding a bunch of like bugs across the stack for vendors and routers and a bunch of things. And so what DPDK was, it was a new approach to bypassing, basically modernizing some part of that IP stack. And so you unload the NIC module. And so typically for boxes that are doing this, you have 2 physical NICs. And then one NIC you unbind from the Linux kernel. And you can do that, either at boot time with boot parameters, or you could do it at runtime. You just, unload that module. And then DPDK and systems like it, I think up and unload by it's an alternative. Then when you load your application, it has this idea of a pull mode driver, PMDs. And so the pull mode driver has like code specific that the NIC provider has built. So either Intel or Solarflare or whatever, and so it'll load that kernel in the application space, and then you tell it which physical device that is not loaded by the kernel at the time to load into the application. And so part of the application bootstrap, right, like part of init, it'll go and it'll find the device, and you have to elevate the permissions of that application, and then it'll bind that physical NIC into your application space. And so what happens is, as long as your packets are less than 8 kilobytes, the 8 kilobytes are mounted directly onto the application space. And so there is no copy between the kernel and user space. It's effectively, how a bunch of the switches are built today. But yeah, so, and then like, what's interesting about that though, is it leads to a ton of different decisions. That RPC, by the way, open source, is called Smurf. It was used by, I think, an Italian database and a couple of, I think, 2 Israeli startups that, and obviously, some large CDNs. But those were the initial ideas that eventually led to Redpanda. And actually, Redpanda is not too dissimilar from those ideas in that, in two foundational things. One is poll mode, right? And so the idea is that if you have a computer and it isn't close to 100% utilization, or 90%, or some like small buffer, then you're basically throwing away money. It's like, what is the point of this CPU but to run instructions? And so poll mode allows you to reduce the latency versus interrupt-driven applications, where like you get an interrupt, then you get an IPI. Basically, you wake up the core, and hopefully that is the core that is designed for that particular port of the TCP stack. And then it's kind of, it adds latency, and there's a bunch of code that you have to do to reduce the interrupt time. I digress. Let me take a step back for a second. But yes, to answer your question, it was about binding the NIC directly into the application space. You wouldn't pay latency cost. And then using this idea of poll mode driver and single thread per core to kind of build applications on top. That was, 2017. That was the test that I did.
Oh, that's really, really cool. I mean, this was stuff I find the whole kernel space and that low level access to hardware really fascinating, but I wasn't aware that you could bind a network card directly into an application like that. So basically, at that point, you're using memory sharing, I assume, so that the data just passes directly into application memory, and you remove all this layer of abstraction that you normally have. Let me ask a broader question, kind of about engineering philosophy. The trend since the beginning of computing is to go to more abstraction. So you start out in the very early days, and people are basically entering the numbers for individual instructions. And then someone comes up with assembly language, so you at least have something that sort of is readable to describe the processor instructions. And then eventually we have Fortran, and then we have C, and now we're on to Java, and then Python, that's even more abstract. And so I think the theme here that you're talking about with this RPC system is to go less abstract, to get closer to the hardware. And if I understand it correctly, that's also a major feature of Redpanda, that you're going to a lower level programming language to enhance performance. And so how should engineers in 2024, I almost said 2023, but 2024, think about going backwards in the abstraction stack? Like, when does that make sense? And when is it a waste of time that will slow down their deliverables?
My hunch is that probably, gosh, 80% of software written could use an order of magnitude improvement in performance. But the way I like to think about latency is the sum of all your bad decisions. It's not, typically there is some architectural stuff, but typically it's like a series of decisions that you make, either because you're pressured for time or whatever. And so sometimes it pays to rethink. It's like, is this really the way, I wanted to build? And now, there's like a very big asterisk here, which is that going against regular paradigms of built-in software incurs, from the software builder perspective, a tremendous tax. And so, for example, when we started writing Redpanda, we use a thread per core. It uses a poll mode driver to reduce the latency on the RPC. It can use, and it uses, most of our deployments use the kernel RPC stack, but the paradigm is still super useful to reduce latency. But the corollary to that is that we had to build our own memory allocators. And so, and then we had to build our own S3 parser, and we had to build our own buffer management pool, and we had to build, and all of those things, just because here's like some foundational models, as the way for people to think about this is, there aren't that many concurrency models and parallelism models for software building. And so, you either have a worker pool, right? And then there's like a ton of paradigms there, whether you're, doing some safe SMR techniques, right? Safe memory reclamation techniques, And there's like, huge research on that around like, tokens and leases and locks and there's like Turing Awards have been given to people that have figured out like, the lock-in semantics of SMR techniques. There's the obvious in the kernel, the RCU by Paul McKinney. Then there's like the thread pool abstraction by Bobby Blumoff, who was one of the early people at Akamai. And then there's what we use, which is a thread per core. But fundamentally, where I wanted to get with this point is that your threading and memory model dictates, by and large, your application architecture, right? And so it is very much tied to the model that you're trying to do. And so for people that are in 2024, that perhaps are earlier in their careers, like choosing a particular library that imposes a parallelism, which is simultaneity of execution, and concurrency, which is software structure, are two of the most fundamental building blocks that you'll make about your applications. And often we do it implicitly. We're like, hey, I need a login library, and bam, it spawns like 6 threads, and you're like, what the hell is this thing doing? Like, why is it taking 6 threads of my memory? Or you want to import an RPC mechanism, and then bam, it's also like a thread per core, and it uses like super expensive lock-in mechanics with global atomics, and it pollutes all your caches. And you just did that because you're just trying to get a hello world up and running. And so over time, you get confident in your skills, and you're like, well, let me make this decision explicit. Let me opt in explicitly into a concurrency and parallelism programming model so that I get the fundamental structures and the performance characteristics that I want out of my software. And so I would just watch out when you're importing libraries. It's very easy to, if you're in Python, pip install X, or import a particular library if you're in Java, and like import like log4j was classically terrible at this, where like you would import a thread pool, or if you're in C++ or other languages, it's very easy to import libraries that are blocking semantics, which is the next Achilles heel. And again, this is like it is the accumulative poor decisions that lead to high latency in your software. And so those would be the top 3 things. So watch out when you're importing libraries, make sure you opt in into your parallelism model, and also opt in your concurrency, which is about software structure. And I make that distinction between parallelism and concurrency.
So let me ask you this. When Joe and I talk to startups about their data stack, typically we advise them to keep it as simple as possible and make it as abstract as possible. And if it's not a core part of their business, basically to just using something off the shelf. And then as they mature, as they get bigger, as they're spending more money, then they can start swapping out pieces and optimizing and really deciding what they're good at, right? Like, what's your secret sauce as a startup? Focus on that. Don't try to reinvent the wheel everywhere. Do you agree with that advice, or would you have some tweaks to it?
Yeah, that's true if you're building product, but not if you're building the platform. To be honest,
yes.
It's the same of the super tired phrase of like premature optimization, blah, 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 blah. No one really pays attention to what it means because no one cares. And then by the time someone tells you that, it's already too late. You're like, yes, well, in hindsight, obviously I wouldn't have optimized this. But if you are the platform, if you are, so databases, logs, servers like Redpanda, indexing, caching, like you are it. You are the platform. Like there's no other place. You own the data, right? Like this isn't an application. You're not gonna send it. This is your problem. You have to deal with right now. It is either going in memory or it's going to disk, or you're gonna replicate it, but you don't have a lot of options. So I think when you design a company to be their platform, then a lot of these things don't make sense. I remember in 2019, the sheer number of people that told me, why are you writing in C++? This is 2019. Why don't you write it in Rust? And I'm sure the Rust religion is going to come and chase you down after this podcast, or whatever other programming language. I was just like, well, one, I don't have to ask you for permission. It's kind of was generally because I'm an engineer and I could just build it. And if it's better, then it's better. And so and then 2, I am the platform. This is where the data is going to go. Like what's it called? I think in English there's a saying, it's called the buck stops with you. I think this is it for this system.
No, that totally makes sense. And I think in some ways you're kind of agreeing with my point in the sense that I think the mistake I see startups making is that they study the history of Google, say, and they think they're Google, and so therefore they're building a product, but they want to build the platform too, and they want to build the entire platform because that's what Google did. Google invented MapReduce, and they invented containers and everything else, but we always have to tell them, like, look, find a standard platform, whether that's open source or proprietary, and use that, because other people are doing this work for you then. And then someday, if you get, big enough to have the resources, then you can be a platform company if you're product. And on the other hand, if you really are just a platform company, then you need to be really, really good at doing one job in an extremely
Yeah,
optimized and cost efficient way.
totally. And we are like not good at most other things, because we don't want to, right? We pay
Yeah.
for an inordinate amount of software. I think software is like the third largest bullet on my finance sheet that we buy externally. Whether it's like our CI/CD pipeline process, could we build it? Sure. For our build system is relatively basic. It's on GitHub, right? We still use CMake. Should we move to Bazel? Probably. At some point when we have a couple of full-time engineers dedicated to the build system. I think it's just like have to choose, and perhaps that's the art is on a business side is being having the right balance between calmness and urgency, and on the technical side is just having the right balance between like deciding when to build versus when to buy. And most times buying is the right thing. We buy more software than we build.
Yeah, that's really great advice. Even though obviously you are an extremely good engineer, you have hired extremely good engineers, and you could build it all yourself, but it's just that cost and time and delays to do that. And again, rather than contributing to an open source community or buying software, you're spending time building something custom that no one else is going to see and no one else is going to benefit from. So
Yeah. Well, saying
yeah,
no, it's one of the hardest thing
yeah,
about building a company. It's just like if I think people have criticized us for not having a compute platform or not having like a SQL engine. You're like, hey,
yeah.
you have this great storage engine. Why don't you build a database? It's like, I know we could, but why would we? Like, companies tend to die from indigestion rather than a starvation. And I just want to be super good at one thing. So that's the advice I was given early in the company too.
Yeah, that makes sense. I mean, so Matt Turk, I don't know if you met him when you were in New York City, but runs Data Driven NYC. And one of his posts on Twitter said that if you really want to be, major unicorn, multi-billion dollar company, you need to be a platform rather than a single product. But my counterpoint would be, don't try to do that early. Like, you need to be really, really successful with one thing. And then if at some point you start saturating that market, or your customers are asking enough and you have the funds and you have the cash flow, then you can think about it. But like, if you try to do that early on and get distracted, you risk undermining your core business or not growing very fast.
Yeah, and you just need a part of the business that's going to fund future
Yeah.
innovation of the product. You just have to have something that makes money. And so for us, it's like, well, you have, either MSK and other companies like Confluent and PubSub, et cetera, all at $1 billion plus in revenue. And so if you assume you can take some percentage, say 20% from each, that's already a very successful public company, right? You're talking about a $600 million annual recurring revenue. And most companies tend to IPO around 200, 250, 300. And so like, we don't have to invent another product right now. It just has to be great at this. And so, I think discipline helps.
Yeah, no, that totally makes sense. Let me back up to something we were talking about before the show started that's closely related to this idea of abstraction, and that is WASM, and how we can talk in a minute about what you're doing with WASM, but WebAssembly, what is it, and how is it changing the computing ecosystem, and where does it sit in terms of level of abstraction? Sorry.
Yeah. So WebAssembly is it's basically an intermediary representation of a language that is portable. And I think the audience, especially the experienced programmers, they're like, hey, that was the JVM, whatever, 30 years ago. And so I suppose this time it could be different. It's different in some pretty critical dimensions. One is it has a bound memory addressability, tend to be 4 gigs. And so that already gives you some multi-tenancy capacity, right? In that you're like, if you start up a computer with 1 terabyte of RAM, then you divide it by 4 gig RAM allocations. And most products in the internet right now, whether it's Cloudflare or Redpanda or like other databases that use WebAssembly as a way of compute extensions with the data, they actually reduce that, because what people are looking for is an ability to inject business out of band policies into the storage engine. for reasons that most products ping pong your data back and forth between a processing system and your storage system. And so whether if you're a database or a log service like Redpanda, right, you get a message and your job is to take Matt's name and then remove the social security number. And so you would enter your name in a table, or in the case of Redpanda, in a topic, something else out of the cluster, right? Because it's like, this is not Redpanda or not the database, would consume that data, remove the SSN, and then push it back into either a different table or a different log, different topic in the case of Redpanda. And so that ping pong happened so much that for one of the public companies, it happened, I think, something like 34 times back and forth just to clean your data from an ad impression till the time that it was delivered to a third-party partner. And so people think that you sometimes make up these use cases, but I was like, wait, when you chat with these people, this is happening all the time in almost most companies. And most people that write pipelines tend to agree with this. If you really ask yourself, what are the pipelines that are really adding value to the company? It's like 2 or 3. Those are the core IPs. And then the bulk of it is doing this in computational terms. It's like dumb data manipulation cleaning. So you take a JSON and you change the shape, or you take XML and you make a protobuf, or you take Avro and you make a JSON, whatever it is, or you enrich it, or you add GeoIP information, or you fence it, or whatever. Basic standard things. One-shot transformations that tend to be simple, but to do them at scale are hard. And so I think this is where WebAssembly fits into the system infrastructure. It allows the programmer, not the software vendor, to write code in their favorite programming language: Java, Rust, Go, JavaScript, whatever it is. And it allows basically the programmer, the end user, to ship that code into the broker or the database in the case of Redpanda, and then change the shape of the data or leverage underlying compute. For us, one fundamental thing that our users have demanded is the ability to embed an AI model into the stream itself. And so PII removal is the classical things. The shapes of the data, let's say you have a JSON object, tend to morph over time. If you're a bank and now today your IP is PII, but tomorrow is obviously your SSN, but tomorrow is your county or your city or whatever, right? Like these laws and regulations tend to change. And you could write the rules of, if, person that name, but the shape of the data may change and person that name may no longer exist. And so you could train a model on a batch of data and then ship it to the engine so that when the data comes in, it can remove the PII and it could expose it in a different topic. And so WebAssembly is a key technology, in my opinion, to allow programmers to ship arbitrary, what I call out-of-band policies of their business into the storage engine.
That's interesting. And I think one thing we've been seeing for several years now is more abstraction in terms of CPU infrastructure. And so it started out, very early 2000s, Intel started to take over from the heavy duty, I'm trying to think, Toshiba and your Spark architectures, these other, like what used to be considered big iron architectures. And now in the last couple of years, we've seen a big shift toward ARM, but then already major tech companies are looking towards what's next because they're a little nervous about licensing and such. And so they've been developing RISC-V. And so I guess one great thing about WebAssembly is you simply don't have to worry about it. As long as there's a WebAssembly compiler for whatever architecture, it's not your problem. It's someone else's problem.
Yeah, exactly. And the end user, and that I think that's been true by and large for most people because they're just not the database, they're not the queue, they're either using Redis or MySQL or Single Store or Scylla, whatever, right? There's like a huge portfolio of databases, and those are the people that tend to worry a lot more about this architectures. Like for us, supporting ARM was actually a non-trivial amount of engineering effort. Could we get it to compile? Yes. But was it as performant as x86? No. And then you tweak it and you enable, ARM v8 with Crypto 5, and you change your compiler flags and you add, different vectorization instructions for your decompression library. And now it performs like world class. And so, but from an end user, to me, I think the key for WebAssembly is they get to leverage their favorite ecosystem. A lot of times, if you remember the store procedures in the Oracle days, like it's non-portable, right? You don't get to use your favorite programming language. You have to use this declarative style. Like you can't program it. You can't change the shape of things relative, all things considered. It's really hard to access arbitrary deserialization libraries. It's like you basically get a tuple and then you output a tuple. And so with WebAssembly, if you're a Go programmer or a JavaScript programmer, you import like wholesale, largely the Go ecosystem. And so I think the ergonomics around WebAssembly are an order of magnitude better than those that came before. I think truly this is where it comes to me. And obviously from a platform for us, it is exactly like you said. It's like, well, today is ARM, and if yesterday was x86 and tomorrow is RISC-V. But also when you talk about GPU and different like computer shapes, it's super useful, right? As cloud platforms tend to bring on differently shaped hardware, right? So you could buy computers with lots of RAM and little disk, or lots of disk and some high network throughput, or whatever it is. I am sure that over the next few years, they're going to start to add more GPUs to this like differently shaped. And so WebAssembly is also a tool, I think, that will allow vendors to leverage differently shaped boxes.
Interesting. And so when you talk about AI models in stream, what type of model are we talking about? Are we talking about something like a transformer model that's analyzing input text and then putting out text in response, in this case with PII removed? And then related question, are you going to be pushing GPUs to like these individual compute nodes where you're running your streaming database?
Yeah, so for those in the audience that are trying to learn a little bit more about this, you have largely, and those that are experts are going to probably squint a little here. So it's like lossy compression, largely directionally accurate, but there's like some pieces that are missing. You have foundational models that are like large and compute heavy, and they require thousands of GPUs and terabytes of RAM. And then you have these business specific models. Think of things that you would see your iPhone have in it, right? So like smarter contact, or like data enrichment things, or geofencing, or automatic format translation, or just document parsing. Like you get utterances from a live call of Wall Street, and you want to enrich the utterance and attach ticker symbols and so on. So much smaller models that tend to fit in relatively small amounts of RAM. Making this up, 1 GB of RAM, 2 gigs of RAM, right? And so like the lookup table is relatively small. Those are the models that I think is what most people will end up using for their AI. Like it's very rare that I think, or at least it is my take, is that over time you'll have thousands of these little very hyper specific models. Like I want to take out my phone, and in the journey to launch a browser or send a text to my partner, like I'm going to interact with a bunch of little models, whether it's going to clean up my text when I send it to her. And so that's the kind of models, small, hyper specific for that particular topic, that are going to be useful, I think, for basically for Redpanda. And so one example, like you mentioned, is this text-to-text response, prompt and answer, but not just arbitrary space of the prompt answer, because that would be a ChatGPT 4. It would be very specific, like you could train it on PII removal, or you could train it on like what the best podcasts in the world, and then it's going to tell you your podcast. It's like a small subset of podcasts.
Yeah, keep the list short. Let's make sure we're at the top of the list.
Yeah, exactly.
Yeah. Well, what's interesting too is to your point about pushing this AI to the edge. Phone manufacturers have actually been doing this for years, although mostly so far, I think, for audio processing and image processing. And so like Apple and Google were leaders in this space to basically put GPUs in phones and then use those with deep models to like process raw noisy images that you get to make really nice photos out of them. And also, if you read like Hacker News, Y Combinator, there are all kinds of people experimenting with deploying these models onto individual laptops by quantizing them with other techniques, and also onto phones. And so, yeah, it seems like this is the time has come to do this. Like we're already doing this in a pretty widespread way, and it's just a matter of getting it into core infrastructure to do the same thing in the back end that we're already doing on consumer devices.
Yeah, and it's very similar to I guess the approach is that both WebAssembly and AI, it's always feel like it's coming, especially for web. It's almost like self-driving vehicles. You're like, well, we've been talking about this for over a decade. When are they going to? My partner could really, she dreams about it. She hates driving. Anyways, so what in a way what we're doing is not revolutionary from the point of view of technology. I think it's just making it accessible as a platform for just the everyday developer. Like, look, at the end of the day, most people are not going to be building a model. They're going to be using Onyx or BERT or some of these models. They're going to be training it and they're going to be teaching it. And you're like, okay, that's the value for the business. I am a bank. I'm a credit card vendor. I'm going to approve or disapprove credit applications. And so I'm going to train it with this hyper-specific context. And then I want to ship it. And then I want to sell that stream to something else. I want to put it in a database or display it on a dashboard, approve credit lines, or send it to another bank or whatever that is. And so that's really where we have sort of tried to come in and where we think WebAssembly is helpful. It's let's give the users a general computing platform that is not too powerful, right? Like you're not going to embed, a Flink application here, but for very context-specific thing is super useful.
Okay, so this takes us right into another topic that we kind of discussed in the emails we exchanged before the show in the last week, and that is open data exchange. And frankly, right now, data exchange is still a big mess. And so obviously you have entire companies built around just the idea of writing API interfaces, because every software vendor has their own API interface with a bunch of like weird quirks and wrinkles that you have to worry about to get it working reliably and to get the data into your system. And so what are your thoughts on open data exchange in the future? You're talking about like process streams being exchanged between companies and sold and such. How is streaming going to play a role in this in the future?
Yeah. My opinion is, I think, divergent from the opinion of other vendors, which is, okay, I understand why they're doing it, because we don't make money on it. And so here's the idea. Most vendors, you can send them their data, right? So take Confluent or take a Snowflake or take a Databricks, right? Like, of course, you can send them your data and they're happy. They may not even charge you when you send them your data. You're like, hey, I'm going to charge you S3 prices. And like, you feel really happy. And you're like, okay, I have a data warehouse strategy. I'm going to send your data to this vendor and it's going to be great. And you're like, well, that's a great strategy if you never read your data. But if you need to read your data, every single query that you run on your data, it's going to basically just drive your build super high. And so to me, the whole idea and the future of streaming is in the presence of a cloud, of a hypercloud context, right? So Amazon, Google, and Azure is to upload our historical data. So today, for the listeners, Redpanda can store an infinite amount of data, and so you can send the data to Redpanda. And obviously, we don't have infinite amount of local disk space, and so we upload it to one of these buckets, whether it's GCS or S3 or Azure Blob Store. And so now that the data is uploaded, today, Redpanda is the only technology that can read it. The format is open, but we've only had one company actually go and read the historical data. And so this is where I saw the dissonance is most data engineers, it's a journey to think of a streaming as bounded and unbounded platform compute where you can sort of unify historical. And so you have to meet them where they are today. And where they are today is they're writing SQL queries joined by some like dbt foo that then outputs onto a dashboard. And the way I think streaming meets developers where they are today, therefore removing one of the Achilles heel, which is complexity, is you upload your data in an open format. So we've talked about this. We're working towards publishing that all our data on tiered storage as an Apache Iceberg table. And so today, you could use ClickHouse or whatever, DuckDB or Snowflake or Databricks or Soup de Jour to just kind of go and query data directly from S3. And if we happen to be the best interface to query your data, well, then use Redpanda. Of course, we could tier it transparently for you. And of course, we can give you over a gigabyte per second over the network. And of course, you can consume it in a streaming way. But on your journey to adopting that, I think it's the realization that we're a small part in a much larger architecture. Now, we're like a core part and super important to the business, but yet just a small part in an engineer's pipeline. And that's different from, I think, where the industry was heading, really, which is you can send us your data and we'll give you, let's say, a Flink as a service, or we'll give you, in the case of Databricks or Snowflake, they'll give you a SQL editor and you can query your data. You're like, yes, but I want to own my data. I want it to be on my bucket under my terms, and I want to I want to have negotiation leverage between Databricks and Snowflake and or whoever is providing you, a SQL as a service. And so this is where I think the open data formats will come in.
Yeah, it really does feel like the time of Apache Iceberg has come. I mean, even Snowflake has signed on, and for a long time they were so resistant to doing that. Now, granted, it's still kind of a semi-proprietary version of Iceberg where they can write to it, but no one else can. But it plays into this ecosystem where you can freely exchange different tools and have a much broader set of possibilities for query engines and such. And so, yeah,
I think
that
the
seems like
public
a
is
very
going
nice
to
thing.
force Snowflake into just adopting a bucket, truly back and forth, both read and writes. Because like the reason they do that is obviously so they control the metadata and they can give you recency of the query, etc. But why not? You obviously very sophisticated people, and so Google already allows that, and same thing with Amazon Redshift. And so I think it's just a matter of time until like the public continues to put pressure on Snowflake to just allow bidirectional access to that bucket.
Yeah. Okay, here's another question. Do you have opinions on cloud data egress fees? I mean, I imagine you're affected by this as a streaming vendor where you're pushing and pulling massive amounts of data, maybe between different locations.
Yeah. The most egregious one is probably the multi-AZ
Yeah.
transfer. It's kind of a racket, and I'm not sure how it's legal by some of the hyper clouds to just give you zero. For their products, they give $0 charge, multi-AZ, and it's like a 30 software secret. It's like every startup in the world knows, and every software company knows, but yet like they could still get away with it. And so that's where I think it's a pain in the butt, and like it's kind of a weird trick because as the company scale, as we like onboard more millions of dollars, right? So I think our like AWS bill is in double-digit millions. And so as you start to onboard and ramp real use cases with like a ton of, then you start to get this huge discount specific for this like data transfers, and you can negotiate, but it takes a scale to do that. And so at the end of the day, it's designed to be negotiated, and so it ends up charging. I think, in my opinion, it ends up taxing the small company, the small innovator, not the larger scale, right? And I assume once we go into double-digit millions, into triple-digit millions, we're going to get an even better discount from AWS and GCP from each platform. And so that's, to me, that's really the most egregious one, because from most enterprise software, though different from serverless platforms, is you end up doing what is known as a VPC peering. Because if you don't, then you're paying like whatever 12 cents per gigabyte as opposed to like 3 cents per gigabyte list price. And so then like you're really incented to VPC peer. And now that you VPC peer, then it's roughly, it's expensive, and it's a pretty large bill from a customer's perspective. But the inter-zone transfer, it's kind of a racket. And then over time, it basically almost goes to zero for most software vendors. So, I don't get it. I think it's a bad play from Amazon. It ends up taxing the young startups. Large companies end up getting a ton of discounts. We started to get some meaningful discounts, and so we can obviously pass that on to our customers. But it's so that's where I think the Achilles heel is of this network is.
Yeah, and I feel like, I mean, it's totally a vendor lock-in tool, right? Like making it hard to get your data out and move it around to other places. But I think at some point, I hope at some point, we'll have enough competition in the public cloud vendor space that someone will say, yeah, our egress fees are going to be way cheaper, and then AWS and GCP will have to follow. I mean, to some extent, that's already happened with Oracle. At this point, frankly, Oracle is a pretty minor cloud player, but they've gotten some really big deals by offering big discounts on data egress. And so I hope that that portends some major changes in the next couple of years, because it really holds back innovation, right? It's not being forced to just lock in on one vendor is not good for anyone from except AWS and GCP maybe.
Yeah, exactly. I totally agree. I actually think I was surprised that Oracle Cloud is decent. I say this just having grown in the times where Oracle was super aggressive to other software companies that even smell like competition. They would just like,
Crush
sue
them.
people. Yeah, exactly. I think now, with their cloud, they probably have a way to like channel their anxious energy into building their cloud, perhaps. And so, but from a technical perspective, it's actually pretty decent. And we've had some customers that are like, hey, will you support Oracle Cloud? You're like, yeah, we will if we have a lot more customers than
Yeah.
than one or two. And so for us, is the major three clouds is the focus. But hey, if Oracle becomes a large one, it's almost a chicken and egg. We'll definitely go where the customers are. And I hopefully over time that'll be a pretty big negotiation muscle for them, and it'll change the industry.
Yeah, yeah, I agree. I mean, it will be nice to get to the point where if their egress fees are much cheaper, you almost encourage your customers to use them and just say, hey, if you're shipping a lot of data out, maybe think about this. And then you have a really big crowbar to negotiate deals with Amazon and Google at that point.
Yeah. Most right, because most large companies are in the hundreds of million, probably maybe not hundreds, but like 50-70 million dollars a year in their at some decent scale on their cloud bill. And so if somebody comes in, it's like, I'll give you a 30% discount. You're like, wow, that is multiple engineering teams or product teams or whatever it is that so it's a meaningful from like a go-to-market perspective impact.
Yeah, and it also changes the game for certain types of IT products, right? So right now, shipping data out in many cases can be cost prohibitive, and so it blocks a lot of use cases. Whereas if you say, yeah, we're going to make egress much cheaper, I as an engineer can think about entirely new use cases in terms of data exchange, and that's what I'm looking forward to.
It'll finally make multi-cloud a reality. It's
Yeah,
like
yeah.
people talk about multi-cloud, you're like, maybe. I mean, you have like one product line on one cloud, another product line on another cloud, but there's not such a thing as a multi-cloud right now. Most
Yeah.
by and large.
Yeah, no, I agree. I mean, and right now it's just so cost prohibitive, and the cost of maintaining on multiple platforms, very different APIs, is very high. But I do hope that that's changing, and like having that these abstractions like Redpanda or Kafka that we can port around will make that whole process much easier.
I agree.
So let's see, we're down to it's 10:47. So what other topics are you really interested in discussing right now as we're closing out? We probably got about like 10 minutes or so.
I think that we probably talked about but most things that are interesting. I would say just to wrap up the whole compute chat, which is like Flink and the competitors and where from a data engineer perspective, and I think people listening to this podcast, like how do we think about it? I think there's like this huge trend of both declarative workload style products, right? So you have like Materialize, you have Arroyo, you have and then there's like a bunch of others in just basically SQL. Obviously, you have Flink SQL being like a subset of that. And then you have the regular code, right? And so in the regular code, you have companies like Bytewax and Flink Table Programming Design. And I'm not sure, to be honest, if we're ever going to like merge both worlds. I think obviously code enables people to build the declarative style compute platform on top. But maybe the missing link will be something like a WebAssembly embedded into these products, into like, so if you could take SQL and at arbitrary points of the DAG computation, you can embed business specific logic or compute. Maybe it'll be the way in which we finally are able to merge into a simple thing. People love the declarative nature, the fact that once you have SQL, it'll attach into a huge other large ecosystem like SQL and dbt and the things that kind of put these things together. But it really lacks when you need to do something more sophisticated, or when you need to snapshot your state differently, or when you're doing like transactions to a different, system that is outside of the streaming domain or outside of the product in which you're doing the processing. So that's a prediction. I think this is where we're heading. Is you need obviously the code platforms, and so as declarative to build the declarative platforms, right? So you need like code, like timely data flow as an example, to build a database like Materialize so that you can have SQL on it. But as this database allows people to onboard computation, I think it'll start to change the game. I mean, it's too early to tell. So far, Redpanda is only one of the few products that offer the user to be able to, inject particular policies of code. And so that's a prediction / I think where a lot of streaming is heading. But we'll see. I think people listening here will probably be the decision makers of that.
Yeah. And I think to your point broadly, I mean, easier abstractions to make this technology more accessible across a broad audience are really what will drive adoption in the future. And so if you give software engineers and data engineers, people with very different skill sets, a common tool set that's very easy to use so they can adopt it quickly, whether they're building an application backend or a data processor for real-time analytics, then you'll see really widespread just an explosion in this technology. And that's been a challenge so far, I think, in the stream processing space, but it is changing.
Totally. I'll say as a parting thought, if people want to learn more about like models or how to embed it, what we're thinking, we have a launch party on January 17th. Feel free to find the details on the website, but it's kind of cool. We're just going to demo. Well, I'm not going to tell you what the demos are, but there's going to be an AI demo of shipping stuff into the stream. So if you want to just like see, it's 8 minutes. I have 8 minutes a slot. And so it's fast, it's punchy, no fluff. Very similar to how we started this podcast. And so if you enjoyed that, feel free to tune in on that. But thanks for having me.
Yeah, it's great having you here. Am I okay to say that I think there's something coming out tomorrow that will be interesting as well?
Yes. Okay. Tomorrow we do have a blog post coming out with more, computational goodness. So feel free to tune in. Hopefully exciting, and we'll see how, some of these things as a vendor, like BYOC was another spicy take. Our open formats was another spicy take by Redpanda. And so we've had this unpopular opinions as a platform vendor for a really long time. We're like, okay, build in C++ and not, Java, like first controversial thing. 2, we built a platform, a cloud called BYOC, which effectively allows you, the user, to use your credits, your Amazon pre-commits, and your specific discounts on instances to run data plane inside your cloud. And obviously, as a vendor, that means I don't get to charge for Amazon. I don't get to charge a reseller fee on base Amazon infrastructure. I have to figure out pricing differently. But we thought this is how people wanted to consume. Tomorrow, there's another similarly interesting launch where I think people are skeptical. So far, we've been right on those two things. So we'll see. Time will tell. But it's interesting to just build the things that you think the world needs, and I'm sure we'll miss. And so I hope tomorrow is not a miss. But it's kind of fun to be built in today. There's like so many cool new technologies for us to leverage and make it easy. So feel excited. So we'll see how tomorrow goes.
Yeah. Congratulations on the success so far, and I hope everything goes really well for these the kind of blog launch and then demonstration upcoming. And looking forward to seeing how your platform and technology evolve and get deployed more widely. I guess we'll close it out there. So thank you so much for joining us on the show, and hope to have you on again sometime, maybe in a year or two, and kind of catch up on how things have gone and how our predictions have played out, what's been right and what's been wrong so far.
Yeah, exactly. Thanks, Matt. Thanks for having me. It was a fun chat, and I'll talk to you soon.
Sounds good. Take care.
Thank you. Bye.